Kirkland Lake is a mining town in northeastern Ontario, Canada, known for sitting atop one of the world's richest gold deposits. Over 30 mines have operated in the area, producing more than 47 million ounces of gold. Today, the Macassa mine, operated by Kirkland Lake Gold, is the only active mine, having recently reached the milestone of 5 million ounces of gold poured. The challenge with mining here is the depth, as the gold lies over 5,000 feet below the surface. To access it, miners descend more than 4,500 feet underground and work through tunnels called drifts. Geologists drill deep into the rock to collect core samples, guiding the miners on where to drill. After drilling, explosives are used to extend the tunnels, allowing further extraction of the gold-bearing ore. When the next shift arrives at the Macassa mine, the muckers begin their work by removing the muck, which consists of debris and rock left after a blast. Some muckers operate remotely using surface-controlled teleremote systems, allowing for safer and more efficient operations. The muck is then sorted, and the ore containing gold is separated from waste material. Once the muckers have cleared the area, the miners move in to reinforce the tunnel using screens and rock bolts, ensuring the stability of the mine. Tools like the jackleg drill and stoppers are used to secure the tunnel and prepare it for further operations. Next, the ore is transferred from the muck pile to ore passes, where trucks are loaded from chutes. The muck is then transported to the ore pass rock breaker, which breaks down the material into smaller pieces, about 16 inches in size, making it easier to handle. After this, the ore is sent to the skip at the loading pocket, which transports the ore up the shaft to the surface. In a notable advancement, Kirkland Lake Gold's Macassa mine became the first in Canada to use battery-powered trucks. These trucks, developed in partnership with Artisan Trucks, help reduce the mine's carbon footprint by eliminating diesel emissions. The trucks have a smaller footprint compared to traditional diesel vehicles, and their batteries are hydraulically loaded and unloaded from the operator's compartment, enhancing operational efficiency. The ore is then transported to the surface for further processing, contributing to a more sustainable and productive mining process. Once the ore is transported to the surface via the skip, it enters a jaw crusher, where the rock is broken down into pieces roughly the size of a softball, around 4 inches in diameter. This is the first step in reducing the ore to a manageable size. The crushed material is then sent via conveyor belts to additional crushers, which continue breaking the ore down into smaller fragments. The final crusher reduces the ore to 7/16 of an inch, about the size of a Cheerio, making it fine enough for the next stage of processing. From there, the ore is transferred to the fine ore bin, which holds up to 1,600 tons of ore, about the weight of 14 blue whales. The ore is then fed into grinding mills, where it is further broken down by thousands of steel balls, each measuring 2.5 to 3 inches. These balls grind the ore into even smaller particles. Once ground sufficiently, the ore moves to another mill, filled with 1-inch balls that help refine the material into a finer slurry. Next, the ore is introduced to leach tanks, where it is treated with chemicals that extract the gold. Once the gold is separated from the ore, it is purified by heating and mixing it with chemicals. The molten gold, which separates from the slag, waste, is then poured into molds and cooled, creating bars. These bars typically contain 80 to 90% gold and 6 to 12% silver. Once cooled, the bars are weighed, stamped, packaged, and sent to a refinery for final processing. Kirkland Lake Gold's Macassa mine is a major asset to the town, employing around 757 workers and 190 contractors. The mine plays a significant role in the local economy and has a strong focus on safety. With the expansion of shaft number 4, the mine will continue to enhance its efficiency, securing its place as a key player in the gold mining industry. The anode bake furnace is a critical component of the smelting process, receiving green anodes from the Carbon South facility and baking them at temperatures reaching 1,200 degrees Celsius over a 20-day cycle. It produces over 600 high-quality pre-baked anodes daily. The anode stacking crane transports baked anodes to the storage facility, efficiently organizing up to 7,300 units for later use. The rotting shop is where each baked anode is fitted with an aluminum stem to prepare it for use in the pot rooms. The stem is inserted into a circular cavity in the anode, and molten steel is poured around the base to secure it. Operating 24/7, the facility produces nearly 400 fully assembled anodes daily, ensuring continuous smelting operations. Each 650-meter pot room at Kitimat contains 96 pots, forming a continuous line that drives the core aluminium smelting process. Anode changing is a continuous and essential process in the aluminium smelting operation at Kitimat. Each pot contains 20 rotted anode assemblies that conduct electrical current from the busbar system into the molten electrolytic bath. These carbon anodes gradually burn out over approximately 20 days due to the intense heat and chemical reactions involved in the reduction process. When depleted, the anodes are efficiently replaced without interrupting the smelting operation, maintaining process stability and productivity. The spent anode material is fully recycled on-site, contributing to sustainability. Enhanced by state-of-the-art gas and fume treatment centers, the facility achieves a 50% reduction in overall emissions, significantly improving its environmental footprint and reinforcing its commitment to clean, efficient aluminium production. Tapping involves siphoning approximately 4 tons of molten aluminium from each AP40 pot every 32 hours, maintaining continuous operation powered reliably by Kamano's hydroelectric facility around the clock. In the casting process, molten aluminium is siphoned from the crucibles and poured into a large holding furnace. It takes 8 crucibles to completely fill one furnace. Once the desired level is reached, the furnace is carefully inclined, allowing the molten aluminium to flow steadily through a trough system and into precision-engineered molds. As the metal travels, temperatures are continuously monitored at multiple points to ensure optimal casting conditions and consistent quality. These temperature controls help prevent impurities and ensure that the final product meets strict specifications. The result is high-quality aluminium, ready to be shaped into various forms for global markets. Krastsvetmet, one of the leading precious metals processing enterprises in Russia, has established a strong reputation for its high-quality jewelry production. Specializing in machine-woven chains and bracelets, the company manufactures products from a wide array of precious metal alloys, including gold 585 degrees and 750 degrees, platinum 950 degrees, palladium 850 degrees, and silver 925 degrees. These high standards of material purity and craftsmanship form the foundation of Krastsvetmet's enduring excellence in the jewelry industry. The company's jewelry production division stands out for its extensive assortment of products. At the core of Krastsvetmet's production are 30 base types of chains. These serve as the foundation for an impressive lineup of 180 different designs of chains and bracelets, showcasing a remarkable combination of innovation and traditional craftsmanship. This variety allows Krastsvetmet to cater to a wide range of customer preferences, from classic styles to more intricate contemporary designs. One of the most strategically significant areas of development in Krastsvetmet's jewelry production is the manufacturing of hollow chains. These chains, known for their lightweight yet durable structure, have become a priority due to their growing popularity in both domestic and international markets. As of today, Krastsvetmet produces 18 unique types of hollow chains, a number that reflects the company's commitment to expanding its product portfolio. Additionally, the production of diamond-cut gold bracelets, known for their sparkling, faceted surfaces, demonstrates the company's expertise in combining technical precision with aesthetic appeal. What sets Krastsvetmet apart is its complete in-house manufacturing cycle. Every stage of jewelry creation, from alloy casting and wire drawing to weaving, diamond cutting, and final polishing, is carried out within the company's state-of-the-art facilities. This vertically integrated approach not only ensures quality control at each step, but also allows for flexibility in design and rapid adaptation to market trends. It also supports the company's ability to innovate continuously while maintaining the exceptional standards associated with its brand. The journey of Krastsvetmet's jewelry production began in the early 1990s. In 1991, a pivotal decision was made to develop a jewelry manufacturing division within the company. 3 years later, in 1994, the production of jewelry officially commenced, with the initial focus on silver 925 degrees items. These first creations laid the groundwork for future expansion and refinement. By 1996, the company broadened its capabilities to include jewelry made of gold and platinum, solidifying its position as a versatile and skilled player in the industry. Today, Krastsvetmet's jewelry production is not only a symbol of high craftsmanship and technical prowess, but also a reflection of the company's ability to evolve with the times while staying true to its heritage. With continuous investments in new technologies, the development of new product lines, and a commitment to sustainability and excellence, Krastsvetmet continues to play a leading role in the Russian and global jewelry markets. Its rich legacy and forward-looking strategy ensure that the brand remains a symbol of quality, innovation, and elegance for years to come. While documenting Sri Lanka's jewelry industry from traditional manufacturing to modern retail, we had the unique opportunity to visit a traditional 22K gold jewelry workshop tucked away on C Street, a bustling artery in Colombo known as the beating heart of the island's gold trade. C Street is packed with hundreds of small-scale shops and workshops, each one representing a chapter in the long, intricate story of Sri Lankan jewelry making. The jewelers used a combination of time-honored hand fabrication techniques and selectively integrated modern tools. Traditional craftsmanship was on full display as artisans hammered, shaped, annealed, and assembled intricate gold pieces using nothing more than hand tools, saws, files, and pliers. This was goldsmithing in its purest form, intense and hands-on. The jewelers used a combination of time-honored hand fabrication techniques and selectively integrated modern tools. Traditional craftsmanship was on full display as artisans hammered, shaped, annealed, and assembled intricate gold pieces using nothing more than hand tools, saws, files, and pliers. One of the most fascinating aspects was their use of charcoal-fired furnaces, fueled by hand-powered blowers. These ancient tools were used to preheat molds, melt gold, and anneal wires in sheets, a practice passed down through generations. Even with electric furnaces available, many preferred the tactile control of the traditional method. The image of a jeweler using a handheld air blower, feeding oxygen to a glowing charcoal pit while heating a crucible, felt like a step back in time. Despite the availability of modern jewelers' torches, several artisans still used hand-blown torches, a testament to their skills and the unmatched precision they offered. Watching one craftsman control the direction and intensity of the flame with just his breath and years of practice was awe-inspiring. With bare feet and legs crossed, shirtless due to the sweltering heat, he was completely in tune with his materials. Piercing and sawing, classic techniques in jewelry making, were being carried out simultaneously across the room. Chains were hand-formed with astonishing speed. The repetition of hammering link after link into perfect shape, then joining them with pliers, was mesmerizing. The sound of metal striking metal filled the air, a rhythmic hum of tradition continuing on. There was one notable mechanized aspect: a manually operated rolling mill used to flatten gold into sheets or roll it into wires. This simple machine stood out against the backdrop of otherwise completely handcrafted work, showcasing a subtle blend of old and new. Determining the purity of gold is a critical process in the jewelry industry, particularly in countries like India, where gold is deeply valued, both as an ornament and an investment. Ensuring the authenticity of gold requires a precise and reliable method of assessment, known as assaying. There are multiple techniques used for this purpose, with fire assay being the oldest and most trusted method, and spectrometry techniques offering modern, highly sensitive alternatives. The fire assay process begins with the extraction of a small sample from unrefined gold, often referred to as doré or scrap. This sample is subjected to an initial analysis using an XRF X-ray fluorescence machine, which helps identify its composition. The weighed sample is then wrapped in lead foil and placed into shallow, porous containers known as cupels. These cupels are preheated and inserted into a cupellation furnace set at a specific temperature. During this process, the base metals present in the gold sample oxidize and are absorbed by the cupel, leaving behind only the precious metals, primarily gold and silver. Once cooled, the remaining beads of precious metals are manually cleaned, annealed, heat-treated to remove stress and make the material uniform, and shaped into small flat pieces called cornets. These cornets usually contain both gold and silver, so the next step is parting, which removes the silver. This is done by washing the cornets in concentrated nitric acid, which dissolves the silver but does not affect the gold. The gold that remains is washed, cooled, dried, and annealed again to ensure consistency before its final weight is recorded, completing the fire assay process. In addition to fire assay, spectrometry methods such as spark spectrometry and ICP, inductively coupled plasma spectrometry, are also used to determine gold purity. Spark spectrometry uses a high-energy spark generated by ionized argon gas, which causes the sample to emit light. This light is analyzed to determine the elemental composition of the gold. On the other hand, ICP spectrometry creates a high-energy plasma from argon gas, enabling absorption spectroscopy, a method that can measure gold purity with exceptional precision, even down to parts per billion. In a monumental feat of craftsmanship and engineering, the Perth Mint has created the world's largest, heaviest, and most valuable gold coin, an astonishing 1 ton. And composed of 99.99% pure gold, this colossal coin has officially set a new global benchmark in the world of bullion. Measuring nearly 80 centimeters in diameter and over 12 centimeters thick, the coin is not only an extraordinary display of wealth, but also holds the status of Australian legal tender. Its creation is a tribute to the Perth Mint's long-standing reputation as one of the world's leading precious metals mints, and it proudly showcases Australia's iconic kangaroo as its central design. The idea for a 1-ton coin was initially thought to be impossible, but driven by ambition and innovation, the team at the Perth Mint pushed forward. After securing legal tender approval, they embarked on the complex process of making the coin. First came the intricate design work, followed by the precision cutting of massive dies and the assembly of a specially designed mold. One of the most critical and daring steps involved pouring a huge amount of molten gold into the mold, believed to be the largest pure gold casting ever attempted. Months of careful finishing and polishing followed, involving a team of skilled craftsmen dedicated to perfecting every detail of the coin. The result is a shining symbol of both national pride and technical brilliance. The decision to create the coin was driven in part by a desire to elevate the global profile of the Australian Kangaroo Gold Bullion Coin Series, one of the most popular in the world. With over 100,000 visitors passing through the Perth Mint's exhibition each year, the 1-ton gold coin now stands as a major attraction, alongside the Mint's existing displays. South African Gold Refinery is a key player in the precious metals industry in South Africa, one of the world's leading gold-producing countries. Situated in a country with a rich history of gold mining, the refinery plays a crucial role in adding value to the raw gold extracted from South African mines and those in neighboring countries. It is involved in the refining, purification, and assaying of gold to produce high-purity bullion, meeting international standards such as those of the London Bullion Market Association, LBMA. The South African Gold Refinery utilizes state-of-the-art technology to process gold into various forms, including bars, coins, and granules. The gold is refined to a purity level of 99.99%, making it suitable for global markets. The refinery follows strict environmental, safety, and quality protocols, ensuring its operations are both responsible and efficient. A major aspect of the refinery's operations is its ability to trace the origin of the gold, supporting ethical sourcing and combating the circulation of conflict minerals. This commitment enhances the refinery's credibility and aligns it with international transparency and sustainability goals. The facility also offers value-added services such as custom minting, secure storage, logistics, and precious metals recycling. The South African Gold Refinery serves a diverse clientele, including mining companies, banks, jewelry manufacturers, investors, and governmental institutions. Its products are widely recognized and trusted both locally and internationally. By refining gold domestically, South Africa retains more economic value from its mineral resources, supporting local employment and economic growth.